In this question, a right-angled isosceles prism of refractive index n. The blue region is the prism, refractive index n. Has a plane of refractive index n1 cemented to its diagonal face. So the diagonal face is AC. The plane, green color plane of refractive index n1 is cemented to the diagonal face AC. The value of n1 is less than n. That means any light from n to n1 will be going from a denser to rarer medium. The assembly is placed in air, surrounding part is air. A ray of light is incident on AB. Calculate the angle of incidence at AB so that the ray strikes the diagonal face at the critical angle. So the light ray incident at AB undergo refraction, bent towards a normal because air to glass. And here n to n1, it's going from denser to rarer. At critical angle, the light will go parallel to the surface. So for what angle of incidence this will happen? That's the question. So right angled B is 90, isosceles A is 45, C also 45. It's a normal at AC where the light ray strikes. Angle of incidence is I on AB. Or angle of refraction on AB is R1. Normal and the refracted ray. Angle of incidence for AC is R2. Angle between the normal and the incident ray for AC. The angle of emergence, when the angle of incidence is critical angle of emergence will be 90 degrees. The marking is not visible, so you can have R1 this angle marked here and R2 this angle marked here. We are applying Snell's law at AB because we want angle of incidence. Sin I by sin R1 equal to second medium refractive index and first medium is higher. So n by 1. From that sin I will be n times of sin R1. N is already given in the question. If you can find sin R1, then you can substitute and get sin I, then I will be sin inverse of that. So for any prism, we have a result. Angle of the prism is equal to R1 plus R2. That result is derived during the derivation of the prism. So we want R1. R1 will be A minus R2. And A is 45 degrees. So R1 will be 45 minus R2. You can substitute R1 here. So sin A will be n into sin 45 minus R2. Use sin of A minus B. Sin A cos B minus cos A sin B to expand the bracket. So n sin 45 cos R2 cos 45 sin R2. So sin 45 cos 45 both are 1 by root 2 comes common out. So sin A will be n by root 2 into cos R2 minus sin R2. So now you can solve y if you are able to find sin R2 and cos R2. R2 is here. If you want to find R2, apply again Snell's law at AC. At AC, sin I is sin R2, sin R is sin 90. R is same as E. That is refractive index of second medium, the cemented slab by the first medium. So N1 by N. From that you get sin R2 is N1 by N. So we got sin R2. If you got sin R2, you can find cos R2 also using cos theta is root of 1 minus sin square theta. So substitute n1 square by n square here instead of that. So 1 minus root of 1 minus Sin R2 is n1 by n, n1 square by n square. Take LCM. You get n square minus n1 square by root of n square will be n. The root will go in the denominator. Now we are okay with cos R2 and sin R2. This is sin R2 and this is cos R2. So substitute sin I is equal to n by root 2 into, instead of cos R2, it will be root of n square minus n1 square by n. Instead of sin R2 will be n1 by n. So you can take common n out and get cancelled from the numerator and denominator. It will be 1 by root 2 into root of n square minus n1 square minus n1. So that's a sin I. I will be sine inverse of that. So that's the first part of the question. Angle of incidence will be sine inverse of 1 by root 2 into root of n square minus n1 square minus n1. Second part of the question, they given the value of n as 1.352. Then calculate the angle of incidence at AB, for which the refracted ray passes through the diagonal face undeviated. So the refracted ray will pass undeviated without any refraction, without any bending, only if the light rays incident along the normal. If the light rays incident along the normal, angle of incidence will be 0. Angle of refraction also will be 0. So R2 will be 0, E also will be 0. So the light will fall for a particular angle so that the refracted rays along the normal of AC. So there is no angle from the normal. Angle of incidence here R2 is 0. Automatically angle of emergence or angle of refraction on the AC phase, E also will be 0. So we already have a result R1 equal to 45 minus R2 for all cases of this particular prism. So R2 is 0 means R1 will be 45 directly. You go to R1 45, then N you have, you can find I using the Snell's law. So sin I by sin R1 is n by 1. N by 1 is 1.352. They already gave. So sin I will be, sin R1 will go to the other side. Sin of R1. R1 is 45 in this case. Sin 45 is 1 by root 2. 1.414 in the denominator. 1 by root 2. And I will be sin inverse of that particular value. That will be the angle of incidence. This value you can calculate using the ratio than the tables.